Hello everyone, my name is Rohit Kataria and today I'm going to talk about rule-based DFM analysis for milling. What is milling? Milling is the machining process of using rotary cutters to remove material from a workpiece, advancing or feeding in a direction at an angle with the axis of the tool. It covers a wide variety of different operations and machines on scales from small individual parts to large, heavy-duty gang milling operations. It is one of the most commonly used processes in industry and machine shops today for manufacturing parts to precise sizes and shapes. DFM. DFM stands for Design for Manufacturability. It is the general engineering art of designing products in such a way that they are easy to manufacture. The concept exists in almost all engineering disciplines, but the implementation differs widely depending on the manufacturing technology. DFM describes the process of designing or engineering a product in order to facilitate the manufacturing process in order to reduce its manufacturing costs. So, what are the rules that we should follow for milling? So, the design rules for workpiece are: number one, we should select a material that minimizes the overall cost. An inexpensive workpiece may result in longer cut times and more tool wear, which will increase the total cost. Rule number two is that we should try to minimize the amount of milling. This is done by pre-cutting the workpiece close to the desired size and shape. Rule number three is we should select the size of the workpiece in such a way that a large enough surface exists for the workpiece to be securely clamped. Also, the clamped surface should allow clearance between the tool and the fixture for any cut. Design rules for features. We should use tools of standard sizes for design features such as holes and threads. Rule number two that should be kept in mind is that we should ensure that the depth of any feature is less than the tool length, and therefore this will avoid the collet from coming into contact with the workpiece. Rule number three is we should be using chamfers rather than a corner radius for outside horizontal edges. An outside radius edge requires a very precise setup and a specific cutter, both of which are expensive and increase the cost of milling. We should drill relief holes before cutting sharp internal corners. So, three inside corners are not possible with traditional milling. One inside corner needs the radius of the end mill. Therefore, relief hole is drilled first and then the corner is milled. Rule number five is that we should be avoiding narrow regions between pockets and also deep and narrow slots. There should be enough space between features so that the milling cutter can move easily. So as we can see in the figures, we should be avoiding narrow regions and we should be avoiding deep and narrow slots. Rule number six that should be kept in mind is that we should be avoiding very long and thin features and undercuts. A feature on a part that will not allow a mold that contains it to slide away along the parting direction. An undercut can either be a protrusion or a depression, hole or pocket, and is described as being either external or internal. An undercut requires an additional mold piece such as a side core or an internal core lifter to form its shape. We should also try to minimize the number of tools that are required, as this brings down the overall cost. So to summarize all that we have covered so far, the design rules for the workpiece are: number one, select a material that minimizes overall cost. Number two, minimize the amount of milling. Number three, select the size of the workpiece. Design rules for features are: number one, design features such as holes and threads to require tools of standard sizes. Number two, ensure that the depth of any feature is less than the tool length and therefore will avoid the collet contacting the workpiece. Number three, use chamfers rather than a corner radius for outside horizontal edges. Number four, we should be drilling relief holes before cutting sharp internal corners. Number five, we should try to avoid the narrow region between pockets, and also we should try to avoid the deep and narrow slots. Number six, we should try avoiding having very long and thin features. Number seven, undercuts should be avoided. And number eight, we should try and minimize the number of tools that are required for crafting our piece.